This is the a little outline on the RC lab. I already uploaded guidelines on how I would like you to write the lab report, and it is in Moodle, so use those guidelines. You have basically 4 sections, and don't forget that all axes should be given unities, and you should be able to keep the digitals, the number of digitals, the significant figures within, reasonable amount. And for this lab, 3 significant digits, it's more than reasonable. But basically, you have your power supply. It's a bunch of batteries, and then you connect those to a capacitor, and boop, it get all charged. So your capacitor should have some initial voltage less than 5 volts. Okay. Now what you do next? You disconnect your power supply from the capacitor, and you connect it to a resistor that you should have previously measured its resistance, right? So to ensure that you are reading everything all right, well, what do? Well, you instead of having a power supply connected to the circuit, you place a voltmeter. Okay. So technically, the voltmeter is reading the dropping voltage across these 2 poles, and the voltage is dropping because the amount of charge in your capacitor is diminishing. So you are basically losing energy in your system because your resistor, once you you close your circuit, your resistor will be dissipating energy. Okay. And as we saw, energy of one capacitor is proportional to the voltage square. So as your resistor is dissipating energy, so the system itself loses energy, which means your capacitor discharged. And if you plot the voltage per time, you're going to have some exponential decay like that. Okay, and you guys did all of that. But basically, the equation describing this decay is given by that. And the point of your lab was to find a measured value for the time constant of your circuit, which is the product of the capacitance C with the resistance R. So if you measure the resistance all right, 150 ohms, we don't have the means yet to calculate or to measure, in fact, the capacitance, but we bought it as 1 Faraday, so this whole thing is 150 seconds. That's the unities of R times C, or ohms times coulomb. So you want to see if your measured quantities, your RC measured, is close or not from 150. So that's the whole thing. Okay, that's what you want to do, and then you get a percentage, and you call this your error. Okay, so basically that's the lab. So how did you accomplish this? Well, you accomplish 2 ways. First, you start out measuring some initial voltage. I'm calling V naught, right? And then you count how long it took that voltage to drop to half of its initial value. Okay? So that when you plug this fact into your equation, you have this much is equal to this much. If you apply natural log to that, therefore your time constant can be, this is t half. By the way, this is not the square root of t, right? It's t half time. It's the time that takes the voltage to fall half value. So your RC measure is t half time. I'll put it like this. Is t half time divided by natural log of 2. And then you have a number, right? And then you have a number. Which is, could have some uncertainty, and you have to discuss that in your lab report. But you got a number. You got a RC measured. Let's call this measure 1. Okay, very good. What is the other way to take that and to come up with another RC measured? Let me show you how. The second way is this. You do the same thing. You start out, you charge your capacitor again. So you plug this in a power supply, right? In fact, I forgot to close that. But you charge your capacitor again, and give your capacitor some initial voltage, right? Some initial voltage, 4.5 volts. And then what you do, you plug it in series with your resistor, and every 10 seconds, so every 10 seconds, you write down a table, the voltage, and then you ended up with a table that is voltage per time with times interval of 10 seconds, so 0, 10, 20, 30, and of course you just read it and plug it in there. You could go as much as 2 minutes, 3 minutes is more than enough. So you don't need to spend too much time. Or if you go to a voltage that is 1/3 of your initial voltage, you're gonna be adding a lot of errors in your circuit. So when you plot your V per time, and then you have all these points, and then you feed a curve, and then you ask Excel to give your trend line, to plot the equation of your trend line so that you can use it. What Excel is going to give you something like this: y is equal y naught exponential minus a number, and I will make that number up. So this is a made up number, okay? X. Now, when you compare this equation, which Excel is telling you, okay, this is the best I can do with the points you gave me, when you compare with this, you realize that those two numbers should be the same, ideally, and your X is T, and this number over here is 1 over RC. 1 over RC. Okay, so 1 over RC is whatever number it comes in there, and then when you flip this number over, you get another measured value of RC. Okay. You could do that, or you could, instead of plotting V per T, you could take natural log of V. In Excel, you just generate a column that is natural log, And when you do your your graphics of natural log of v with t, you're going to have some straight line, right? And the slope of your straight line, so this slope is 1 over RC, right? Which you can derive from this. So V is equal V naught, V naught E minus T over RC. So natural log of V, natural log of V naught minus T over RC. So when you plot natural log of V per T, this slope is 1 over RC. Okay, so your report, you should show that, you should indicate you understand what the physics of it is, basically. Okay, good enough?